Hi guys, this is our video for 9-1. So some calculator skills that you need to have in order to do this lesson are square roots and squaring. So square root is on your calculator, and if you're using the school calculator, it's going to be above the x squared. So here's our calculator, and the square root, it's really hard to see on this picture, but the square root is right here above x squared. So you're going to hit the second key, and then you're going to hit the x squared key, and that's going to give you what you want to the calculator to give you the answer. Okay, so the square root of 25 is 5, and that's kind of an easy one because 5 times 5 is 25. Square root of 90, you really have to have a calculator for that because there's no number that you multiply by itself to get 90. Okay, so the square root of 90 comes out a really big long decimal, 9.48683, and so on. We're going to always be rounding our answers to the nearest tenth for this chapter, so I'm going to round it to 9.5. 3.4 squared, okay, so this symbol is square root. This little 2 here, that's our x squared. And again, that's a button on your calculator. You can type 3.4 times 3.4, but it's faster to hit the squared key, less typos. And that's 11.56. And 19 squared is 361. So those are some calculator skills that you need for this chapter. The learning target for 9-1 is to determine if three numbers form something called a Pythagorean triple. Pythagoras is a famous mathematician who discovered some really cool properties about right triangles. Okay, so Pythagorean theorem says that if you have a right triangle, then you can figure out the three sides. They have this special relationship where if you square two of the sides, it will equal, and then add them together, it will equal the third side also squared. Okay, so A, B, and C, what are those? Well, A and B are legs. So I'm going to use some color coding here. A and B are the legs. And the legs are going to be the two sides of the triangle where the right angle here is right in the corner. Okay, those are your legs. Then you have the hypotenuse, which is represented by the letter C. And that's your hypotenuse. And that's that side that's going all the way diagonal like that. Okay? And here's some kind of fun ways to remember it, okay? If you think about the triangle as being like the legs of the stick figure, the legs are the stick man legs, and then the ground would be the hypotenuse. Find x. This is a funny meme that I found a number of years ago. The student was supposed to find the value of x and how large it is, and then they just pointed out where it was. It's just funny. And this is another fun graphic that Mrs. Smith and I put in the flip chart, where CC, representing the letter C, is the hypotenuse, like hippo and hypotenuse. I can't even say it. Anyway, what we're going to do today is next identify the legs and the hypotenuse, and we're going to use highlighting, okay? So I'm going to use yellow for the hypotenuse and blue for the legs, but I'm going to do the legs first, okay? Because I see the right angle in the corner, and that tells me that those sides are the legs. And it's very important for this whole chapter that you can identify in a diagram where the legs are and where the hypotenuse is. So find that right angle, and the legs are the two sides coming out of it. The hypotenuse would be that longest side across from the right angle. So it's important that we know that that's the longest side, because when we start doing today's lesson, the longest side would be the largest number in the group of three numbers we're about to be given. Okay, so is it a right triangle? That's the main question we're trying to answer when we're doing our assignment. A right Pythagorean triple is three numbers that would form a right triangle. So first we're given the numbers 3, 4, and 5. So for 3, 4, and 5, I know that 3 and 4 are legs and 5 is the hypotenuse, because 5 is the largest number. So 5 is your C. So what we're doing is we're essentially doing a little proof. We're going to sub the numbers in, 3, 4, and 5, as in the color-coded way that you see, and we're going to see if we have an equality at the end. Now, forgive my handwriting. Okay, so I've subbed in 3 for A, 4 for B, and it really doesn't matter. The A and the B, you can switch them. I could have written 4 squared plus 3 squared. It doesn't really matter. But it's really important I put the 5 underneath the C, and don't forget the little squares. Okay? Then, I'm going to put the left-hand side in my calculator. Okay? And, oops, spoiler alert. 3 squared plus 4 squared, I'm just going to type that right in, and I get the answer of 25. Then I can look at the other side. 5 squared, also 25. So when they both come out the exact same number on both sides of my T-chart, that would be a yes. That means if I have a stick that's 3 feet long, and a stick that's 4 feet long, and a stick that's 5 feet long, and I put them together, I can make a right triangle. Now, not just every set of three numbers works this way. So next we'll look at 6, 5, and 4. Now, 6 is the largest number, that's why it's yellow, and it's going to go in place of the C, because the largest number is the hypotenuse. So again, we're going to sub in 5 squared plus 4 squared. I'm going to put the 5 squared plus 4 squared all into one calculation in my calculator. And I get 41 on the left-hand side in my calculator, and then 6 squared is 36. Those are not the same number, so that's a no. They would make a triangle, but it wouldn't have a 90-degree angle in it. Okay? 11, 15, and 13. Again, let's pay attention to how I've colored. 15 is yellow because it is the largest number, and the largest number goes under the C. So 11 squared plus 13 squared is 15 squared. Maybe, maybe not. Okay, 11 squared plus 13 squared, well, that equals 290. 15 squared is 225. They did not come out the same, so that is also no, not a right triangle. Maybe some other kind of triangle. 5, 12, and 13. 13 goes in for C. 5 squared plus 12 squared is 169, and 13 squared is also 169. So that is yes, that would form a right triangle. Okay, these are diagrams that are deliberately drawn to trick you. It looks like there's a right angle in this corner, okay, but maybe it's not. So we're going to use Pythagorean theorem to see if we're being tricked, okay? 18 is the largest number, so that is going in for C. 12 and 15 are my legs, so I've got 12 squared and 15 squared. And then on the other side of the line, 18 squared. 12 squared and 15 squared make 369. 18 squared is 324. They are not equal. So that is a no. Let's move to the middle example. 25 is the largest number, so that is the C. Subbing in, I've got 15 squared plus 20 squared on the left-hand side, and I've got 25 squared on the right-hand side. Well, both sides come out 625 when I put them in the calculator. So that means yes, this actually is a right triangle here in the middle. Okay, so this one was not, but this one is. And our last example, we've got 7, 3.5, and the 10. Sub them in, 3.5 squared plus 7 squared, and then 10 squared on this side. They do not come out equal. On the left-hand side, I've got 61.25, and on the right-hand side, I have 100. So they are not the same. My O moved. Get back up there. That is a no. They are not, this is not a right triangle. Thanks for watching, and have a good day.